the Physical Science Section 17.2 lesson video, and as always, if you like my videos all in one spot, then just subscribe to my channel. So we're still talking about mechanical waves, so we're going to do some calculations in Section 2 with wavelength and frequency. So obviously we need to discuss what those things are first. So any motion that repeats at regular time intervals is called periodic motion. The time required for one cycle, a complete motion, that returns to its starting point is called the period. And so of course our complete motion, when we're talking about a wave, would be one wave itself. Any periodic motion has a frequency, which is the number of complete cycles in a given time. Frequency is measured in cycles per second or hertz. So when we use hertz, it's cycles per second. So seconds is in the denominator. That'll become important when we're doing calculations. So a wave's frequency equals the frequency of the vibrating source producing the waves. So if you look, different waves have different frequencies. If you watch the bottom wave, less wavelengths pass than the top because those wavelengths are shorter. So the top wave would have a higher frequency because more waves pass this line in a given time. It's the same thing up here. This would have a higher frequency, this would have a lower frequency if they're moving the same speed. So wavelength is the distance between a point on one wave and the same point on the next cycle of the wave. So most of the time we say wavelength is crest to crest or trough to trough, but it's actually any point on one wave to an equal point on the other. It's just easiest for us to find two crests and two troughs, so that's why we usually use that. Increasing the frequency of a wave decreases the wavelength, because if we're moving the same speed, in order to make more waves pass in a given time, we have to shorten the wavelength. So in other words, frequency and wavelength are inversely proportional. As one goes up, the other goes down. So the formula for the speed of waves is speed equals wavelength times frequency. Wavelength is represented by lambda, and frequency is represented by nu. So speed is going to be in meters per second. Wavelength is almost always in meters. We'll do an example where it's not today. And nu, or frequency, is in 1 per second or hertz. You can write either and they'll both be right, but you cannot write seconds. It's either 1 over seconds or hertz. So here's one where clearly I did not animate it, so it already came up, so we'll just look at it together. So it says one end of a rope is vibrated to produce a wave with a wavelength of 0.25 meters. So there's my lambda, or my wavelength. The frequency of the wave is 3 hertz. So there's my frequency. What is the speed of the wave? So I'm looking for my velocity or speed. And so you gotta be careful with the V and the nu. The nu, I always draw it as a little more of a rounded V to kind of help myself keep the two separate. So we know speed equals lambda times nu, or wavelength times frequency. So I plug in my wavelength of 0.25 meters. I'll plug in my frequency of 3 hertz, but I put 1 over a second because that's really a hertz, because then you can see that a meter and a second will not cancel. So when you do 0.25 times 3, you're going to get 0.75, and then your units would be meters per second, which you know that's the unit for speed anyway. Okay, so hertz, sometimes it helps to write 1 over a second so you can see what's happening with those units. So let's look at a couple more. So as always, maybe pause the video, try these on your own, and then we'll look at them together. So it says a wave on a rope has a wavelength of 2 meters. So there's my wavelength. And a frequency of 2 hertz. There's my frequency. What is the speed? So I'm looking for speed. Alright, so we know speed equals wavelength times frequency. So then I just plug in. So my wavelength is 2 meters. My frequency is 2 hertz, which I'm going to write as 1 over a second. And so obviously 2 times 2 is 4. And a meter and a second do not cancel, so my unit is meters per second, like that. Okay, so the hertz kind of confuses people sometimes. So like I said, if you want to change hertz to 1 over a second so you can see what's happening with those units, you're more than welcome to do that. Alright, so pause it, try the second one, and we'll look at it together. So it says a wave in the water has a frequency of 4 hertz. So there's my frequency, and a wavelength of 0.1 meters. So there's my wavelength. What is the speed of the wave? So again, we're looking for speed. We haven't had to rearrange yet. We'll look at some where we have to rearrange, of course. So speed is wavelength times frequency. So I just plug in. My wavelength is 0.1 meters. My frequency is 4 hertz, which I'm going to change. I'm going to change to 1 over a second. And so 0.1 times 4 is 0.4. And then a meter and a second do not cancel, so my unit is meters per second. Okay, so you got to get used to realizing hertz is 1 over a second. It's really cycles over a second, but we just don't write cycles. All right, so let's look at what happens when we have to rearrange this formula. Because as I say in all my videos, you got to be able to rearrange a formula. So it says, what is the wavelength? So this time I'm looking for lambda. What is the wavelength of an earthquake wave if it has a speed of 5 kilometers per second and a frequency of 10 hertz? So there's my new. All right, so speed equals wavelength times frequency, but this time we're looking for wavelength. So what do I do with frequency to get it on the other side? Well, remember, you do the opposite mathematically. So right now we're multiplying the two, so I divide it to get it on the other side. So in other words, wavelength is speed divided by frequency. So then I just plug in. So my speed is 5 kilometers per second. My frequency is 10 hertz, which is 1 per second. And so if you look, the seconds will cancel, and this time I'm left with kilometers. Remember I told you the wavelengths a lot of times in meters, but not all the time. All right, so 5 divided by 10, of course, is 0.5, and then my unit that I'm left with is kilometers this time. Now, if it had asked me what is the wavelength in meters, then I would have to change that. But since it just says what's the wavelength, I can leave it in kilometers. All right, so maybe pause the video, try this bottom one, because you're going to have to rearrange, and let's look at it together. So it says a wave travels 1.8 meters per second, so that's its speed. And, this should say has. Oh well, typos. And has a wavelength of 1.2 meters. So there's my lambda. What is the frequency? So this time we're looking for frequency. So again, we know speed equals wavelength times frequency. So if I'm solving for frequency, I need to get wavelength on the other side. So I do the opposite. The opposite of multiplying is dividing. So I divide by wavelength on both sides. So frequency is speed over wavelength. So then I just plug in. So my speed is 1.8 meters per second, and my wavelength is 1.2 meters. So those meters cancel, and so then 1.8 divided by 1.2 is 1.5. Now, the unit that a lot of you will put is seconds, but remember, it's not seconds. This is over. This is, here, let me rewrite it like this so you can see it better. This is per second. So you have two choices. You can write 1 over a second, or you can write hertz. Either answer is fine. But I'm really picky about units, so make sure you get your units right. Okay, so 1 over a second or hertz. So hopefully that formula is not too bad. Hopefully you're getting used to using formulas at this point. Alright, so if you assume that waves are traveling at a constant speed, then wavelength is inversely proportional to frequency. So inversely proportional means if wavelength increases, frequency decreases. If wavelength decreases, frequency increases. So, well that's what this says right here. So if one goes up, the other goes down. So if you look, this has a short wavelength compared to this. But if you watch, it's counting how many waves pass at a certain point. So if 1, 2, 3, 1. 5, 6, 7, 2, 8. So we had about 8 waves pass on the top and only 2 waves pass on the bottom. So this has a high frequency and a low wavelength because look how close the crests are together. This has a lower frequency and a larger wavelength because you can see how far apart the crests are. So next thing is amplitude. So we talked about crest, trough, wavelengths, amplitude. The amplitude of a wave is the maximum displacement of the medium from its rest position. The more energy a wave has, the greater its amplitude. So for amplitude, you start at your rest position. Remember, the rest position is an imaginary line like an equator that goes through the center of a wave. And then you can look at either how high a crest is, or you can look at how low a trough is. Either one will give you your amplitude. So amplitude is the height right here. So you have 2 different amplitudes. Here we have a large amplitude, and here we have a small amplitude. So what does that show us about energy? The greater the amplitude, the more energy. So this wave has more energy than this one does because it has a higher amplitude. So, section assessment. How is wavelength related to frequency for waves moving at constant speed? They are inversely proportional. Remember, if one goes up, the other goes down. They are inversely proportional. How is the energy of a wave related to its amplitude? The higher the amplitude, the higher the energy. Or you could say they're directly proportional. The higher the amplitude, the higher the energy. All right, number 3. If you double the frequency of a wave, what is the effect on the wavelength? So remember, these are inversely proportional, so they do the opposite. So if we double one, what's the opposite of doubling? Well, it cuts in half. Okay, the opposite of doubling something is halving something. Okay, so the wavelength would be 1/2 the original wavelength. If I had said tripled, we would have cut it to 1/3, like that. All right? So, I already have the answer up here. Boy, I'm not doing great on this PowerPoint. All right, so let's just look at it together anyway. Hopefully you didn't try this one on your own. So a wave on a rope has a frequency of 3.3 hertz. So there's my frequency. And a wavelength of 1.2 meters. So there's my wavelength. What is the speed of the wave? So I know I have my answer right here. Let's just look at it together. I need to go back and check my PowerPoints a little better. So we have speed is wavelength times frequency, and so then I just plug in. So my wavelength is 1.2 meters. My frequency is 3.3 hertz, which I'm going to change to 1 over a second. So once I do 1.2 times 3.3, I got 3.96, which you can clearly see I just rounded to 4 here. And then a meter and a second do not cancel, so my units would be meters per second. All right, so hopefully you're understanding how to calculate either speed, frequency, or wavelength for a wave, and understanding how frequency and wavelength are related. They are inversely proportional.